Good day, students. The topic we are considering today is equilibrium of force, and the subtopic under it is moment of a force. Moment of a force is the turning effect of a body about that point. And the moment of force is also the force, the product of the force and the perpendicular distance from the line of actions from that point. Now let's see. Moment equals force times perpendicular distance of pivot to the line of action. Since force is in Newton and the distance is in meters, the SI unit of moment is expressed in Newton meters. It is a vector quantity. The force, if it's in Newton, the distance is in meters. When you multiply them together, give you Newton meters. Let's see example. See the figure 1.0. The force is perpendicular to this distance, but the second diagram, figure 1.1, the force line is not perpendicular to the distance. What you will do is that when you are given a question like this, you just put a dotted line to take it straight up, and you now bring the dotted line to the center of gravity. At this point, you trace it to that point. There will be 90 degrees that shows that it's perpendicular to the force. At that point, you'll be given the theta, angle theta, whether 60 degree or 30 degree. Let's analyze what I'm trying to say. Now, let's assume our force is given to us to be 5 Newton. The distance is given to us to be 2 meters. Now, in this case, since force is perpendicular to distance, direct, now you now have moment M equals force times distance, which is 5 times 2, which is 10 Newton meters. But in this case, the second diagram, the line is not perpendicular to the meter rule. But in the first diagram, figure 1.0, the force is perpendicular to the meter rule. The way you calculate moment in the second diagram is different from the first diagram. Since it's not perpendicular, you use dotted line to take it up, take the dotted line to the center of gravity, and try to resolve this line. You have D as the hypotenuse. This is the hypotenuse. This is the opposite to this angle, and this is the adjacent. We need this opposite. Let's assume that you are given force to be 5 Newton, distance to be 2 meters likewise, and the hypotenuse is giving you, we are giving hypotenuse to be 2 meters. Yes, as a distance, we need to get the opposite, which is perpendicular to the force. Now, let's resolve it using SOHCAHTOA. You see that sine involves opposite and hypotenuse, which is D. Now, write sine. Let's assume the theta is 30 degrees. Now, sine 30 degrees equals opposite. What's opposite? Just take it as opposite over hypotenuse, which is D. Our hypotenuse is D. It's represented with D. Opposite equals D sine 30 degrees. Now, opposite equals, what's D? That's 2 times sine 30 degrees. But sine 30 degrees is half. It's half, 0.5. 2 here 1, 2 here 1, which is 1 meters. This one is 1, opposite is 1 meter. You can now come back to write moment equal to force times perpendicular distance. Perpendicular distance. We have resolved it here to be force times D sine 30 degrees. And don't forget that force is 5. Our distance now, we are using d sine 30 degrees instead of normal d, and we have calculated d to be 1. That's 5 times 1, that's 5 Newton meters. See, please take note, when you see a diagram like this that's not perpendicular to the meter rule, you resolve it to get the opposite using SOHCAHTOA. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.